Hi, question number 3 taken from June 2015 A-Level Maths HSC M1. A plane is inclined at an angle of inverse of sine 1 over 8 to the horizontal. A and B are 2 points on the same line of the greatest slope with A higher than B. The distance AB is 12 meters. A small object P of mass 8 kilograms is released from rest at A and slides down the plane, passing through B with speed 4.5 meters per second. For the motion of P from A to B, find the increase in kinetic energy of P and the decrease in potential energy of P. 3 marks for the first part. Okay, so let's try and do an illustration here. We have this plane inclined at an angle here, let us say alpha. Okay, and we have a point here. A is higher than B on a line of greatest slope where AB is equal to 12 meters, right? So this object is released from A and goes down. As it passes here, it has a velocity of 4.5 meters per second. Now we need to find the gain in kinetic energy at B. What is the kinetic energy at A? At A we don't have any kinetic energy. It is zero. We only have potential energy. So at A the object will have at A the kinetic energy is equal to 0. But at B we have kinetic energy. At B the kinetic energy is half mv squared. So what's going to be half mv squared? So half times 8 times 4.5 to the square. And if you work this out in a calculator, you'll end up with 81 joules. So now the gain in KE, kinetic energy at A, is going to be 81 minus 0, because there it is 0. So sorry, at B, and therefore it's going to be 81 joules. Now what is the loss in potential energy at B? We should know the potential energy at A. What's the potential energy here? What's the height anyway? This is also alpha. This is 12. So the height h is going to be 12 times the sine of alpha. So that's going to be 12 times 1 over 8 as given in the question. So this is h. Now what is the potential energy at A? Potential energy at A is going to be mgh, which is basically 8 multiplied by 10 multiplied by h, which is 12 times 1 over 8. Work all of that out in the calculator. So it's going to end up with 120 joules. So this is the potential energy at A. Therefore, when the object has moved down and it reaches B, it will lose that potential energy at B. Therefore, it will lose the 120 joules. Therefore, loss of P, potential energy at B, is going to be 120 joules. So here we are for the first part of the question. Now for the second part, we need to find the magnitude of the constant resisting force that opposes the motion of P. Alright, now let us move on to the second part. So let's try to see what's happening here. The object was here at A, then it came all the way down at B. Now the potential energy here was 120 joules, and the kinetic energy of at B was 81 joules. Okay, so what's basically happening? The object is going down, so we need to find the resistive force. The work done by a resistive force is equal to the resistive force multiplied by the distance moved from the point of application. So what is this resistive force? Work done by resistive force also is going to be the loss in PE minus the gain in KE. So resistive force multiplied by the distance, the resistive force which we need to find multiplied by the distance 12 is equal to the work done by resistive force, which is loss in PE 120 joules minus 81 joules. So therefore the resistive force is going to be 120 minus 81 is, I suppose, should be 39 if I'm not mistaken. Yeah, it should be 39. So here we are, 39 divided by 12. So the resistive force to the motion of P is going to be, if you cut that by 3, you're going to get 13 over 4. And so here's the answer. The resistive force to motion was 13 over 4. Okay, you can give it as a fraction or decimal, whatever you want. So this question is taken from June 2015 A-Level Maths HSC Mechanics 1.